That's starting. And we're live. Okay. Send this out to all the Twitters. I should keep that in a separate. Let's get a little screen copy. Wait, I think that showed a Slack notification. Let's try that again. Close enough. And webpack, whiskey, code splitting. Could this not get any better? I don't think so. And link. Oh, Twitter links. And
check for typos.
Dude, I'll purposely do. I know I should. We are live right now. Webpack, whiskey, code splitting, left pad. Could this not get any better? Hashtag JavaScript. Boom. And now we play the 5-minute waiting game. This is always super impromptu, and like last night I did it and it was just okay. Struggled to code basic JavaScript, but it really helps you get used to people just silently watching you constantly code. And you're just like when I was doing it, I don't know, a couple months ago, like I started feeling pretty good. I was like, all right, let's just do this. And we're updating to ES6. Yeah, you were there too.
Oh, yeah.
I felt really comfortable in my shoes doing that. Okay,
wow.
So Nebo's. We got this.
You got all of these. I don't know how you did it.
Okay, so that went out. I should actually go to that YouTube page though to make sure we have people there. Pause myself. Oh my God, we're live. Cool. Anyways, so I figured what I was going to do about code splitting. A bunch, none.
None?
Oh, was I cutting out?
Okay. Good.
I said, how much do you know about Webpack code splitting?
How much do I know? Let's say like none.
Cool. Nice. Well, that's okay. No, that's good. You don't have to say anything at all. You could just be here and be like, sounds good, Sean. Shut up now. It's kind of late. Okay, it looks like maybe like one more person is filed in, so that's almost good enough for me.
I'll retweet it.
Oh, nice. Yeah. Oh, hi, Corey Hickson. I should have like a little marquee that says like brought to you by Buffalo Trace Bourbon.
Was that the new sponsor?
Crap. Nah.
Yeah.
Buffalo Trace Bourbon. Ooh, why don't we? Oh my gosh, that'd be a good idea. Right, there's some code splitting. There might be. I'm going to do not a lot of coding code splitting, but I'm going to teach you under the hood. Like maybe I'll just show you an example from the source code, and that's about it. I wish I had glasses, but deal with it. Oh. He's gonna laugh at me when I say or do something stupid. Maybe like Sean.
We'll see.
that command deletes folders. You don't want to do that.
RMRF dot.
Ooh. Well, Mr. Travis, Webpack is not that mysterious. It's just really scale, and so it can be kind of complex looking. So I'm just gonna. Oh, okay. We got like 15 people here, so I'm just gonna start. Hi, everybody. I'm Sean Larkin, one of the maintainers for Webpack, and today we have we have Henry. It's Zhu, right?
Zoo.
Official pronunciation or Zhu?
Just say Zoo, like ZOO.
Zhu. Henry Zhu. Left pad on Twitter at left_pad. Main Babel. So we're gonna destroy your night tonight, but not really. It's gonna be fun. So I'm gonna try and make this short but educational about how code splitting works. Some people might be like, "What is code splitting?"
Me too.
Well, yeah, code splitting was GWT, Google Web Toolkit. Did you ever write GWT?
I know about it, yeah.
I definitely did not. Yeah, GWT was like kind of the scary Java-based web stuff, but it inspired Tobias Copper, the original author, to do code splitting or to implement it in Webpack. It's one of the first features. And so I think what I want to do first is we're going to jump on my, brought to you by Microsoft Surface.
Too many sponsors.
And Buffalo Trace Bourbon. And I'm just going to try and draw to the best of my abilities kind of what a dependency graph looks like to Webpack. If I actually have those files in Slack, it's too late. I'm not even going to bother. I'll pull them up on this side. So there may be some folks out there who don't know what a graph is. Hi, everybody. Hey, Alex and Besh and everybody. Oh, Tiago. What's up, man? Well, so anyways, if you should jump on the chat. I think you can do this. 144p. Anyway, so a graph data structure is kind of the feature of Webpack because it allows you to start at a root node. So let's just draw a node. Hey, I'm a node. And then we're going to, this kind of represents a collection of data, and it points to another location. So an edge to a different node. To Webpack, we have specific terms for these things, or for these nodes and edges. So instead of a node and an edge, we call them dependency block. I'm just going to call it dep block. And inside of them are pointers to other dep blocks. Deps or dependencies. I'm just shortening them for space and terrible whiteboard planning. How's it? Guys, can everybody see things okay? Does it look like crap? It's like watching a Minecraft stream. I don't know if that's good or not, but let's just go with it. Except with booze. So yeah, we have, let's just call this like the root node. Okay. Make sense? You get that. Henry is way smarter than me. You went to school did you do software engineering or computer science in college?
Oh, well, I mean, I took some classes, but I didn't major in it. So.
Okay, so that you're at least that many powers greater than me. So you get this root node. Yeah. Root node is just the first place in a, what do they call it? A directed dependency directed acyclic graph. I think that's what it's called. But anyways, so the dep is going to point to another location. Let's just give it a name. So a.js and b.js.
Mhm.
Det block is this abstraction that we have in Webpack. It's part of our object-oriented collection of classes. And so it has dependencies.
Mhm.
And essentially what's happening is we construct a graph. So, I just want to make it maybe a little bit easier with a sketch. We'll do another one. So you might see, let's just color this one tree. And we have some, well, let's just consider these all det blocks or nodes. Just call them whatever you want. And it'll make sense once I show kind of some of the hierarchy. So we have a dependency steps. One points to here, one points to there. And let's say this one points here and this one points here. Yes, we understand how a graph works. How does this all come into code splitting?
So all the dependencies are files, right?
Well, yeah, it's kind of, so like block itself doesn't have constraints about how, like files, or it has to be a file and a location. Really, all it is an encapsulation of dependencies. So it's just a arbitrary collection of location, obviously with code inside of it. So like if you really wanted to get crazy and dive into Webpack source someday, you could maybe build a, I don't know, a database module or something like batshit crazy. So you could do that. So let's take a snap over to, I'm going to do a share screen on my side to a graph. Show you guys some images that are kind of cool. So let's see how I can do this without looking like an amateur. This and snap it out. Is there any questions so far? Does anybody have questions?
Question.
Works better. Throw me some questions here, folks, while I'm trying to struggle through getting this image to show up on the Google share screen. Here we go. You don't. I'm not going to be offended.
So the root node is just the entry points for Webpack.
Yeah, so the root node in Webpack are the entry points, exactly. And, that's where Webpack starts to build the graph. So like some of the common conceptions people have, isn't jQuery working? Well, if you know jQuery, it's not really a module. It doesn't use a module system. And so there's no true explicit dependency statements that Webpack can create dependencies, in the object modeling to point and build other nodes in the graph. It's just one big ass script to it. Okay, so I think we got this here. So we're going to do share screen, application window, and failure. Okay, I'm just going to share my screen as kitchen. Okay. So, and we're going to switch back over. Okay, so you can kind of see that a little bit. Ish.
It's
Have it
still
pointed towards there.
it's still on the other page. Oh, okay.
It switch finally. Maybe. This is one of our, I guess they call them UMLs, or like, I don't know what it stands for, but dependency, like I said, is a top level class that is kind of like an abstract class if you're into types and type systems and stuff. But it has inheritances of all of these other subclasses. These specifically define how a type of dependency and what kind of statement you're using. So keep that in mind. And now we're going to switch to the other diagram. Okay. Who's taking notes? Kavinsky, you better be taking notes.
Oh,
Okay. He's in there. I know he is. Okay. Now, okay, can you see this one? Kind of, sort of, maybe. All right. So hopefully it switched over correctly. So this is dependencies right here. And this is the same thing. This is a UML, but this is the other super important class modeling system. So if you look at the top level class here, we have dependencies block, and they have a reference to dependencies, and it's an array. So there's your those are your adjacent nodes. But the kicker is that these are also treated as adjacent nodes. You can see it's a self-reference. You might be like, what? It makes no sense.
What?
Yeah, I know, right? But this is the coolest part. So if you look at the subclassing, whenever you see in webpack source code, it's actually just a dependencies block. You know, a module is just a JavaScript file that has a physical, you know, location and a resource path, and it belongs to a chunk. You know, it can be context. You know, there's all, you know, this is kind of another abstract class with some abstract properties, but then most of them are normal modules, and we're just going to talk about those right now. The other sibling class here is async dependencies block. And if you look at the subclasses there, you might be like, these kind of look familiar to something I recognize. Dependencies block, require, ensure, AMD. These all kind of seem similar to the 3 ways you could do code splitting in Webpack. So async dependencies block is code splitting. So I think let's jump back to the other screen. Woo, okay, no more screenception, and I'll stop this here. Okay, did that kind of, so you got that in your mind now? We got these async dependency blocks?
Yeah, a little bit.
Okay, so here's the kicker. I'm going to start drawing. So we know that, you know, these are all dep blocks, you know, but most time, because that's like it's an abstract class, you're really going to see them as, you know, like normal module. And the dependencies, you know, which are like these edges, are going to be like a comma JS require dependency. Dependency. Yeah. Oh God. Yeah. That's so unreadable. Okay, let's change it. Yeah. JS require. Got an I. Dep. That's just as bad. Okay. Anyways, so like that's kind of how the graph works. Now, let's go ahead and now I'm going to draw it again and say, well, Sean, how does code splitting work? So you saw that graph here can also have references to other. You follow me so far? Remember that from the graph? It had its own self-reference. Let's see what chat's saying. How confused are we? 5. Guys, how are we doing? It's very hashtag dep blocks. I love it. Sorry. It makes me so excited. When anyone talks about the Webpack source code, I'm just like, yes. Oh my God, somebody might get it. It's just like, as a maintainer, you're just like, oh, my work is done. Okay, so let's do this again. So I'm going to do this. We're going to call these are dep blocks. And let's say these are deps. Stop it. Microsoft Service. I love this thing. Everybody go buy one. No, that promotion was a little, that was moist. Okay. And let's call these, let's not. Well, yeah, let's do it. Let's do it. How do I want to reference that? A dep. And then here, since we know what a dep block is, why don't we, since I explained how the subclassing works, let's try this. let's call this a normal module. Sound good?
What's a normal?
So a normal module is a subclass of dependencies block.
Okay.
Normal JavaScript module. Nothing fancy about it. It has dependencies, points to another location.
Okay.
There's some other types that do special things, and we leverage that class system to be able to explore other options. Like, for example, the way that we have thought about approaching our system architecture is creating another subclass of module to be, we'll talk about that after. But so, okay, let's draw the graph. Too much rambling. So we got our entry point, and it's going to be a little bigger. And let's say we're going to be, I'm just going to give it the name. So A, oh shoot, I already messed up. Here we go. 3 depths. You know, dependencies, cool. They are pointing to 3 other locations. YouTubers, if you are following me, or if something doesn't make sense, please scream. All right, now these are pointing to other normal modules. Cool, cool, cool. Here's where it gets kind of badass. So let's call this async dep block. Well, okay, let's call it by its usable import dependencies block. Okay, so we know that this is actually a dep block. Cool. So code splitting in a nutshell is this. This is so much fun. Okay, so you have, let's say, just, you know, we got entry JS. We got A, we got BJS, CJS, cool. Lamest example ever.
That's pretty normal.
But then, yeah, it's pretty normal, you know, like standard webpack explanation. Here he goes again. Good file name conventions. It's nice and descriptive. And so let's just say, okay. Lazy.js. So now remember, this is a pointer. Boom. That is code splitting right there. Lazy.js. So think about it, and it'll make maybe a little more sense once let's just say this has another dep. This could also have just like some normal dependencies that point to other locations. Let's just say D. So so what Webpack does here is it traverses the graph. It builds it out first. So what it's doing is it scans and it finds, oh, here's a require statement. Here's a a require statement. Here's an import statement. Let's throw it all in here. These are dependencies, and give them their proper subclass. And then we point to this module. We repeat the same step in a breadth fashion. So it builds out the immediate neighbors, and then it goes flattens them into one array or a queue, and then it starts doing the same thing. Oh, where do you belong? But what it's also doing is that it comes across a special statement that is a require ensure, a system.import, or a import. It creates an async dependencies block. dependency for it, and it puts it inside as a reference underneath an existing block. What we've done is we've created kind of like a isolated but system, because like when you think about it, so like if I was to draw it inside of here, let's pretend like it's in here, you still have dependencies inside that are pointing, to the same location.
Where are you drawing?
But see this right here. See how I've made 3 little tiny baby depths?
Okay.
I think of it as like nested, kind of inside, because it is its own encapsulated environment, and it provides a separation for boundaries of the modules. So what is Webpack doing? So as it's created, it builds a graph and it shoves everything into a chunk. So done is it says, okay, let's throw everything into a chunk. And this dependency block statement is inside of this chunk. But what it also does is it says, oh, holy shit, you have a block that's referencing a block. And so everything inside of that subtree is now created into a separate asynchronous chunk.
Okay.
And really, it's the exact same pattern. It just recurses until the graph is finished building.
Mm-hmm.
A poll of anyone watching still. How many even watch? Oh, there's 21. Oh my god! So, guys, did that make sense at all? Validate me here for a moment. Have we gotten it from a architectural graph level? Maybe. We'll jump back to it. Okay, Aaron is sounding very positive. Anvesh is extremely excited so far. This is good. I think so. Okay, so people who don't understand, I'm not going to go and say this is a safe place, because even though it is, that's like, this is a safe place. Ask whatever question you want. Just, I'm happy to help explain. Henry, did anything not make sense to you? You might answer people's questions. I might answer yours and answer somebody else's.
I mean, I guess you just explained that you're parsing through the code to find the dependencies, and that's it.
That's yeah.
Okay.
And that's really that's all it takes, is that when it finds a specific one that's asynchronous,
Right.
the data is instead it's a block that lives inside of a block versus a block that has a dependency.
Okay.
So the edge itself is a dep block instead of a dep. Special template, but at the same time, it's also a subtree, because a block is essentially a node on a tree. But this is also saying a block and a block. It's kind of like you've created a mini tree inside of this one that's encapsulated.
And so you said that anytime you see like a lazy.js or like an import, that's when you make a new chunk?
So it's not when you make a new chunk. So it's more like, actually, that's a great question. So answer Aaron's question. So what did you mean with first building the tree? So essentially, Webpack has to understand the entire dependency graph first, and separates them into separate pieces and locations. And so for Webpack to be able to say, oh, I know to separate everything with inside this area right here, and what the hell everything has in it. So that's the first step. Okay, so look in the code now, and I'll try to explain it a little bit. It's not that scary. I actually think I talked about well, here, this is what we'll do. I'm going to pull up a photo that I made. Let's see, where are my photos? How do I figure this out? Hey, there's Yuho. My first time using this.
I have no idea.
Is it photos? I can't remember. My scary clown. Okay. Actually, this is so cool because there's two really great at this. So how does a dependency become a module? So here's the process of a graph, and then I'll actually show you in the code how chunk order deals with async dep blocks. Cool. I'll answer that, Ambush. That's a great question. So look at this diagram really quick. It's kind of like what I ran through, but now we're using a little bit of webpack terminology. How a dependency becomes a module. Because you know that to build the graph, it has to take those nodes that it parses in the entry point, and it actually needs to create additional modules to then parse and build the tree out, right?
Mm-hmm.
So here we go. Oh my God, dude, it's so late. Okay, so we're gonna wrap it up and shoot for 7 minutes.
Cool.
All right. So the first step is resolve. We make sure the dependency statements, so like require, import, whatever, make sure that that file exists. So it's like, oh, hey, look, you are from where you came from. But then it also smacks a bunch of information, like its location, the request that the user made, loaders it parsed from it that match against it. It says, basically it talks to, quote unquote, it gets sent to the normal module factory that essentially checks to see if you have any loaders first. Once it does so, it says, okay, we need to parse these because I don't actually recognize you as a JavaScript file. Once it transforms that through loaders, then Webpack, or maybe in the future Babylon, to parse all of the dependency statements from this newly created module.
Okay.
And then what it does is it adds those dependencies there, but then it will then build out that graph, as it continues through the process. So it turns it into a module, but then also smacks dependencies on it. And then it gets sent to the compilation. And then the resolve process is just, it recurses. So cool, that makes sense, I think. Does that make sense?
What is the compilation step?
So the compilation is essentially where all of the dependency tree building happens. But it also is where it's kind of like the main. So the compiler just delegates events to the compilation and applies specific plugins based on options. I can show that in the source also. Okay, so how do I get back? How do I get back? Oh wait, it's just that this is hiding. I should hide this. There we go. Back to, no, I remember my first time. Oh crap. Oh, there we go. Yeah, we got it. Okay, so yes. So this is actually how Webpack traverses the graph.
Okay.
So we have the first step that's right here. And let's just, for funsies, turn this on so I can diagram a little bit. And let's do it in white. So we have this area right here. Basically, they're iterators. The starting point is actually this queue. So we take a block and the chunk it belongs to. And then you start with that one, and what it does is it looks and it says, hey, do you have any blocks attached? Do you have any dependencies? Do you have any variables? Variables is for another time. It's not terribly important. I'd plug in. And then what it says is it passes it through this iterator dependency, which it takes and adds the module to the chunk, pushes it to the queue. And then it does the same thing with blocks, adds to the chunk, pushes it to the queue. And then this while statement basically says, hey, well, while you have crap in the queue, pop it off, remove it, and then repeat the step. So now let's look into some source. So I think we can get away with that. That is not where I went to. There we go. Let's see if it loads. Da-da-da-da. Had some source, list source. Okay, cool. So we have a step called, so what was your original question again? You're like, how does it know?
My question?
Yeah, or I think you had a question like, how do I know when it's adding dependencies, or where does it do it? It was the one before I went on a side rant just now. It's okay if you don't remember.
I don't know.
You know what? You can, if you're late for work tomorrow, I'll write you a note. Because you're up so late. I feel bad, actually.
I don't think I'm going to be late.
Okay. So where did we talk, guys? Where do we leave off? Okay, all right, let's answer some questions, and if it pops up. I was kind of wondering how chunk order deals with async dep blocks. Okay, so what's really cool is that with async dep blocks, chunk order, yeah, I know, right? Chunk order isn't really a big deal because it is asynchronous, and so there is some sort of condition at one point in time that is requesting that dependency. So, like a system.import returns a promise, but that's going to be triggered from some conditional code, or let's say your router or a router event. So that really isn't a big deal. There shouldn't be any ordering issues. Oh, you wanted to know how it puts it in the chunks, I think, in separate chunks and whatnot.
Yeah, something like that.
Yeah, I remember. This is, go back. Okay, cool. So this is the seal, and I probably have to maximize this, I'm sure. They're gonna be like, you can't see. Guys, who's all with me still? Henry is sleeping. No, you're not sleeping.
I'm half awake.
Okay, so in that segment, we've only lost 2 people, so we're doing good.
We just left it on.
Yeah, okay, cool. Okay, yeah, so, yeah, you're right. Good point. So this is called the seal phase. So we built out a dependency graph. So we have this fancy graph, and now it's time to actually take this and separate it into its kind of containers, ready to generate files based on these containers. All that a chunk is a subtree of the graph. And so the first thing that happens is you'll see, can I get my pen to, I gotta check the battery on that. Okay, so let's do screen sketchers, except let's hide this since we don't need it anymore. It's more visible. Cool. We need video from 8. They want to see you right now.
Oh,
Stop. Oh, you can. It's okay. We don't mind. Don't make them pressure you into anything.
Oh, I don't feel pressure at all.
Yeah, do it. Then I'll pressure you. No, okay. So we have these prepared chunks. So a prepared chunk really isn't, instead of actually code, I'm just going to tell you what it is. All it is the entry module, the entry name that you get from the entry property. And then I think it's like the actual module itself. So like M module in an array. or in an object. I can't remember. I think it's in an object.
Mm.
Cool. That was cute syntax. So what's happening, Sean? Each module call the add chunk function. An add chunk essentially is going to generate a new chunk. It does like new chunk, and then it also takes and does a backwards reference so that you can interchangeably reference them from whether if you're in the chunk or in the module data, they point to each other. So, you know, like mod. Now remember, a module in this case is a dependencies block. Just remember that. So we go chunk add module, and then it does the backwards reference. And then there's some depth information, like how deep in the tree is it? So if you ever wanted to look at the depth property on a module, if you're writing a custom plugin, you can do that. And it takes and calls this function right here. This is the magic money function. Process dependencies block for chunk. So you're probably like, what? So remember, the graph has already been built out at this point. And so really what you're adding to the chunk also has references to all the other modules. And that's part of this kind of like add process. So let's jump to that part of the code because this is the most important part. Process dependencies block for children. I think it's go to symbol, right?
Is it in that file?
Yeah, it is. Cool.
Oh, okay.
And hey, does that look familiar? That was the computer science in action sketch. As you can see here, it goes through block, dependency, and then also variables. So to answer your question, how does it know to add to create a separate chunk when it finds an async block? Well, it's actually right in this code right here. You'll see it. Is right. Let's do a cool color. Oh no, did this just die? Oh good, we're good. We're okay. Got a little scared for a moment. It's probably because it's like, oh, my battery's good. Okay, so right here. What this is saying is, because what this is doing is it's looking for it. It takes a block, and then remember it was going through each property inside the block and iterating on it. It was iterating on a dep block, a dep, and the variables. Iterator block function, and it says, well, if this doesn't own a chunk, then we need to add it to a new chunk. And so this add chunk property, what it's doing is it starts from that async block, and then it's traversing down the graph and adding into its own respective chunk container.
Okay, so you're saying that block didn't have a chunk before.
Well, yes, correct. So because this, like, if you think about, this is the block, let's say this had the import statement.
Yeah.
That gets converted into that gets added to the blocks array, not the dependencies array.
Oh, okay.
And this doesn't actually have a reference to a chunk itself. So it's kind of like a crafty, clever way of determining whether or not it already belongs to something or not, and that it's async. Anytime that a block... Say what?
What's the difference between the block and a dependency?
So if we jump back, I know this was like the craziest part for me to get. So the difference between a block and a dependency is if we jump to let's try the fancy swipe. This is like my favorite part. I can like swipe. There we go. So, oh God, how did you, what a mess. So again, a dependency is, so a dep block
Yeah.
has 3 properties on the object or on the class.
Yeah.
Has dep, dep block, and variables, but whatever. So a dependency is just a edge on the graph, another dep block. A dep block inside of a dep block, it is still kind of an edge, but it's also a signal to the compilation to create its own container asynchronously.
Okay.
I know, guys, the terms are, I will,
Very vague. I mean, I can't tell what it is from.
they are. And so I spent a lot of time trying to figure this out myself because it made no sense. Maybe let's pretend we call it something else. So in a dependency graph, what if we called it like this? This a module. And we called this a import statement. And we called this a require statement. So these are dependencies. And they point towards the location of another module. Same thing, another module. But then there's also inside of here a system.import call. System.import. So this reference also references, but it gets a different class. And we can actually, let's say we call this a module also. But it's a pointer to another module, which again is just a graph. And so it could have the same dependencies and so on. So I'm just going to call this module, dependency. So you follow me so far?
Maybe.
Okay. And I think maybe so. Dep block is, yes, when it's nested inside another dep block. So long story short, understand as developers and modules in our graph, Webpack just simply abstracts them to a higher order class called blocks. Because really, all a JavaScript file is a collection of dependencies that point to other locations. Dependency sack. Dep sack. That has other dependencies. But if you think about it, you're like, well, I have another dep sack in here that has its own ecosystem, and I want to load it conditionally. So yeah, I mean, this is good though. I really like the feedback, but it's, oh my God, we went like 12 minutes over. To me, that's very clear. Dep block chunks. Cool. All right, guys. Henry, totally leave if you want to.
Okay.
Does anybody else have any questions? Everybody thank Henry for coming on. Thank you so much. Thank you so much. I appreciate it. Dude, go to bed. I can tell you're tired. I can fight these guys here. I'll fight them. We'll talk. We'll talk more. Yeah, thank you, Henry. All right, man. Have a great night. I'm just gonna do some cleanup now. Hashtag cleanup.
Hashtag clean.
That's like what Miles does all the time. See you, man. Talk to you later.
Okay, bye.
Okay. So, I mean, you guys can all, like, how many people are actually, oh my God, there's still 18 people here. So, does anybody else have any questions? I can explain this further. I really want to drill this into your head until it makes sense. I think this is one of the most confusing parts about Webpack is that everything we've done it to scale. And because of that, it adds a bunch of what some people consider unnecessary abstractions or complications to the source code. So remember, I'm gonna pull up a file again. We'll take a look at it real quick. If I can find my Hangout screen. Here we are. Okay. This share screen transition is brought to you by Microsoft Surface. Excellent tool for developers and education. So let's share the entire screen here. Screenception. Okay, so let's jump back. So if we look at the properties we have here, dependency block. I know it seems confusing, but if you look, everything right here is also considered a dep block. So a normal module has these three properties. They have dependencies and they also have blocks, which are lazy reference, or essentially they're just pointers to other modules, but they're signals for code splitting. So is that, you know what, I'm going to open up for questions here. Who has questions? And I'm just trying to find my share screen. There we go. Stop it. Maybe while I'm waiting for questions, since there's like a little 2-second delay, I'll just redraw this graph and try to see if I can figure out how to make it make sense. Force it down your brains. Okay, so let's add another sketch. Cool. Yeah, or so let's see. Let's do this. So we've got this right here. Foo.js. Oh god, that was bad. Let's put it underneath foo.js. And we also, oh, where are we? Okay. Let's just say if I can write tiny pseudocode that hopefully you guys can read. Okay, so let's just do const foo. Oh, that's unrealistic. Const bar. No, let's do real world examples, guys. Don't, okay. Let's say const app equals require app. I'm not going to do paths. Let's just go with it, okay? And then let's just say for fun, let's just say like const analytics. Let's just say GA. Let's just say we're just wanting to load another script, like Google Analytics. It's not really part of your app, but you want it everywhere. Totally a terrible example. Require, you're like GA, like that's a thing. Okay. Making sense so far? Yep, I think so. I mean, I can read that, so. So the first, so like literally what Webpack starts out with is exactly what you are looking at right here. It's just one module. That's all it sees. Might have other entry points, and it kind of performs this kind of in parallel or asynchronously, but aside the point, I think. So what happens here? Let's just say this is a dep, and I'm going to call it a dep block. I know it's confusing, guys, but I think you understand that everything that was in that hierarchy, a module and like normal module, context module, they're all dep blocks. I think once you understand that, it'll make more sense. You can think about them like modules. Let's just say that. Module. So Webpack says, uses acorn parser, turns it into an AST, and it says, oh, holy crap, I have a require statement. Let's take that require statement, and we are going to smack a dependency onto this file here. And then it does the exact same thing. Boom. Well, now what happens is that these dependencies first have to go to the resolver to resolve their locations. So resolves. So maybe we can pretend this is the resolving step. Like, I'm seeing if I'm actually a place that I exist. And it does. Hey, how about it? Oh no, that's bad. Let's make it black. It's inconsistent. So we know we exist here. Hi, Constantine. Thanks for joining. It's my pleasure. It's not often I get to actually find people who give a crap about this stuff. But when you guys do, owe me one pull request in Webpack. It doesn't have to be like core. It could be. But I'm going to hold it to you. I know everybody chatted in here. Anyways, hey, see you, Travis. Yeah, we could talk later, for sure. Anyways, so we have found that it exists and it resolves. We're going to do the same thing here. Now, if it didn't, that's when you get those module errors like, hey, this doesn't exist. I can't find it. That's what that is. All right, so we got app.js, and let's just say, GA, this is a dead end. It's just a script, just loads it in line. It's got nothing in it, just some code. Got the codes. Now, let's say this. We got const, oh crap. I'm not on my, so like have my computer attached to the base for battery life, so it's harder to draw with. Let's just say like nav. Let's just pretend it's a nav equals require I think it's important to show you that they are both synchronous. So let's just say import nav. Cool. We'll pretend that's a thing. So the same process happens. I'm doing this a little out of order. But then later on in your code, let's just say, I know, right? So in the code, let's just say you have like an if conditional that's like, if like a user clicks something or whatever, doesn't matter. Then I'm just going to do the dynamic import statement. It's the same as require ensure. It's the same as system.import. Import modal. I think modal is a really great use case for this, especially if the modal code is being constructed with JavaScript and not already like nested in a hidden DOM or something. Oh crap. Okay, there we go. And then, like dot then get the module back. Module, blah, 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 blah. So my friends, This webpack is like, oh wait, we're gonna convert this instead of a dependency into a depth block. But what it's also going to do is it's going to continue to traverse the graph. So the same way, da 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 da, and this modal might have like a modal header, modal footer component, modal body. That might be in that actual code. Let's just do something simple like this, like crap. There. Okay. So you might actually see those static, synchronous import statements also there, like import, la 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 la, la, same thing. Well, that's just 3 sync dependencies. Same way, builds the graph. Anyways, I'm beating a dead horse here. So the only difference that we've seen here is that a depth block is when Webpack knows to treat a is when the chunk itself, one, doesn't have a name, and unless it's required, sure. But also it's when a block, which is also a module, has a block inside. That's it. And so when it's time to actually the seal phase, Webpack goes, all right, guys, everybody hop on the bus. And then they're like, oh, no, not you. Because during that iterator dependencies, it actually says, oh, well, you belong in a separate. But since it's add chunk, what it does is it then scans all the dependencies here that are sync and says, okay, you guys all hop in the same chunk for the ride. So what we get resulting is, like a main.bundle.js and then a 0. Whatever bundle.js. I think usually we end up with like a 0.js or something. 0.js, because that's the chunk ID. So like drill at home. Does anybody have questions? You get like literally, I'm going to give you 4 minutes because then it'll be 11:45 for me. Oh, you like that? I should have just taken it, took it slower. Yeah, and like when thanks, Aaron. I'll have to, like, I don't know, maybe draw like a little, like, make a GIF that like captures this in a little like higher speed. There you go. I'll consider it a contribution if somebody takes a subsection of this video and converts it to like a long GIF that I can share on Twitter. I think people will really like that. It's not that you had to do it slower, but oh yeah, concrete examples. Yeah, I know. The abstract, it is it's hard to wrap your head around. The way I think about it is like this. I'm going to share my screen and we're going to hop over for a second. So when you dive back to this beautiful graph, everything that's a module to me, when I see it, is just a sack of dependencies or a dependencies block. And when you have an async one, it's kind of like just a boundary. See, because it's like an edge, but it also has a reference to that module that the tree is then built out of. And that's kind of how I see it, I guess. Whether it's right or wrong, who knows? So I know you probably didn't learn how to do code splitting per se, but you understand how it works behind the scenes. We process. This is what the best way to say is this is why Webpack treats everything as a module. So it's not just JavaScript. A loader could return a system.import statement around some sort of file. And, it's going to process it that way. So you could get really crazy and creative and lazy load images or some stuff. And really, I mean, it's kind of like the high level. It's like the high level under the hood explanation. It's really more about the science of the graph. And something that I challenge you guys to in the last minute here is, or actually here's really cool. So I'm going to leave you with something to think and obsess about. Whether you actually obsess about, who knows? So you may be like, it's all in compiler.js. And so the traversing of the dependency graph is going to be in compilation. You want to just start at the add entry method. So, and that was for Swap Neil Mishra. Hopefully I didn't butcher your name. If I did, I'm sorry. So anyways, I want to leave you with this example. Why is it oh crap. How do I get back to where I was? Why is it powerful that we can have these abstractions around blocks and things like that? So the reason is that, remember how I told you how most things are just normal modules? Well, think about the concept of trying to implement rollup into Webpack. How would you think we would do it using our object system? Well, we have all this great inheritance. That a dependency block is just a collection of dependencies that point to additional places, right? Makes sense. So rollup is really hoisting all of those into one module and then singularizing or uniquifying, deduplicating the dependencies and having one module scope. So an idea that I ran by Tobias, and he kind of confirmed that was his approach, is that instead of we have a normal module, it would be as simple as I say that with quotes. Well, why don't we just create a class called concat module? And it stores references to dependency blocks. And inside its constructor, we'll take dependencies and singularize them. So like 1, 2, 3, 4, 5, 1, 2, 3, 6, 7, 1. Well, this would actually, as a process, this would give us 1, 2, 3, 5, 6, 7. Boom. That's how rollup works in a nutshell. So I'll leave that for you guys to maybe obsess about or maybe not. That's kind of the architecture that we're thinking. We're going to throw it right there at, right next to normal module as a subclass, to dependencies block. Otherwise, guys, thank you so much. It was a good time. Yes. Yes. Totally not concat source. Not to be confused with concat source. Thank you, Kavensky. But anyways, Thanks. And if you feel motivated or want to get involved, and let's say you just don't have the time to contribute to the code, you can always donate to our Open Collective and help support us there. It helps keeping me doing this kind of stuff. And yeah, so thanks, guys. And spread the word and the knowledge if it excites you. And why I do this stuff today is because I love being able to teach. So have a good night, guys.